The satellite telemetry tells a story of erasure. Compare the basin data from 2014 to 2025. The shift in color is not a seasonal anomaly. It is a signal of systemic failure. The lifeblood of the American Southwest is draining away. Zoom in on Arizona, a state where civilization defies the environment. Millions of people, massive industrial farms, and sprawling megacities exist in a place where the geography screams uninhabitable. They survive on a single variable, imported water. But look closer at Phoenix. The Colorado River is nowhere to be seen. The city is fed by a divided water supply. One half drinks from a distant, dying river. The other drinks from a local, protected reserve. This is the Arizona paradox. And as the drought deepens, this division is no longer just a quirk of infrastructure. It is the difference between survival and collapse. To understand the crisis, you must understand the machinery. Arizona is powered by two separate colossal engines. The first is the Central Arizona Project, or CAP. It is a 336-mile concrete artery, pumping water uphill from the Colorado River. It serves as the primary water source for the majority of Arizona's urban population, but it relies on a source that is rapidly disappearing. The second is the Salt River Project, or SRP. This system captures water from the local Salt and Verde rivers, storing it behind a fortress of reservoirs. It is older, smaller, and crucially local. Here lies the cruel irony. When drought strikes the Colorado, the CAP dries up. Yet, simultaneously, a heavy winter snowpack can cause the Salt River system to overflow, forcing operators to spill precious fresh water into the desert just to protect the dams. One system is starving, the other is spilling. In a logical world, you would simply move the water. But in the physical world, gravity stands in the way. The systems occupy separate basins. The geography prohibits transfer. CAP can send water downstream to SRP, but reversing that flow, sending the surplus uphill to the starving sectors, was deemed geologically impossible. Water does not flow uphill until now. Enter the interconnection facility. The plan sounds deceptively modest, a connector pipeline less than half a mile long. But the engineering required to make it work is an act of brute force against physics. Because the CAP canal sits at a higher elevation, gravity refuses to cooperate. The solution? An industrial water elevator. A massive pumping station designed to lift millions of gallons of water vertically approximately 200 feet effectively, creating an artificial river that flows backward. It is a $250 million switchboard for the state's water supply. It turns two rigid, isolated systems into a single, flexible fluid network. It allows Arizona to bypass nature's limitations. But there is a catch. The project is currently trapped in the design phase. Construction is not expected to begin until 2027. Completion is projected for 2030 if the timeline holds. The Colorado River is not waiting for the permits to clear. The river is dying on an accelerated timeline. Arizona is already operating under Tier 1 shortage status. This is not a drill. It is a federal mandate cutting the state's Colorado River allocation by hundreds of thousands of acre-feet annually. For the engineers in Phoenix, this is a logistics problem. For the farmers in Pinal County, it is an extinction event. Pinal County was once the agricultural heartland of Arizona. Cotton, alfalfa, barley. These farms were built on CAP water, and under the state's water priority system, agriculture was placed at the bottom of the list. When the cuts came, the farms were first to go dry. In 2022, Pinal County farmers were told to fallow tens of thousands of acres. Some accepted compensation through fallowing programs, payments to let their fields turn to dust. Others watched generations of family legacy evaporate with no buyout in sight. The priority structure was designed to protect drinking water at all costs, and it works for the cities. But it has created a sacrifice zone, a ring of dying farmland encircling the urban cores that remain, for now, insulated from the crisis. If the drought persists to Tier 2 or beyond, the CAP could lose half its volume. The buffer disappears. First, the farms go dry. Then, industry. Finally, the taps in the suburbs stop running. The hierarchy only delays the reckoning. It does not prevent it. With the interconnection facility years away, The state has been forced to look for water in places that were once unthinkable. Necessity has rewritten the rules. If you cannot import water, you must recycle it. For decades, treated wastewater was relegated to golf courses and cooling towers. It was legally unfit for human consumption. But in 2025, the regulations changed. Welcome to the era of advanced water purification. In facilities like the Cave Creek plant, wastewater is forced through ultrafiltration, reverse osmosis, and advanced oxidation. It is stripped of pathogens, pharmaceuticals, and dissolved solids until it is molecularly purer than most bottled water. In industry terms, this is direct potable reuse. In public discourse, it is often called toilet to tap, a phrase that undersells the sophistication of the process. Phoenix is betting its future on the principle that water is water, regardless of its origin. But they aren't just looking at the sewers, they are looking at the agricultural runoff. Near Yuma sits a sleeping giant, the Yuma Desalting Plant. Built in the 1990s and largely kept in standby mode for decades, this facility is designed to strip the salt from agricultural drainage water before it reaches Mexico. It is expensive, it is energy intensive, but it is capable of reclaiming tens of millions of gallons per day, an emergency brake for a system running out of options. The question is no longer whether Arizona will drink recycled water. It is whether the infrastructure can scale fast enough to matter. But while Phoenix invests billions in surface water solutions, a quieter crisis is unfolding beneath the soil. Arizona's groundwater aquifers are ancient reserves water that accumulated over millennia. In theory, they are the ultimate backup. In practice, they are being drained with almost no oversight. In the 1980s, Arizona created active management areas, regulated zones where groundwater pumping is monitored and restricted. Phoenix, Tucson, Prescott. These cities operate under strict water budgets. But step outside these boundaries, and the rules vanish. In rural counties like La Paz and Cochise, there are virtually no limits on groundwater pumping. Industrial farms, some backed by foreign investment, have drilled deep wells to irrigate water-intensive crops. Alfalfa, pecans, crops destined for export while local wells run dry. Residential wells that served families for generations are now pulling up sand. The water table has dropped hundreds of feet in some areas, and because these regions fall outside the AMAs, the state has limited authority to intervene. This is the second Arizona paradox. The cities are regulated, monitored, and adapting. The rural periphery is a free-for-all, draining the underground reserves that everyone may eventually need. Groundwater was supposed to be the insurance policy. Instead, it is being cashed out before the real crisis arrives. However, creating new water is pointless if you lose it before it reaches the destination. The Colorado River has a silent predator: evaporation. Billions of gallons vanish into the arid atmosphere every year. Water that was captured, pumped, and paid for, simply dissolving into the sky. In some stretches, the Siap Canal loses a measurable percentage of its flow to the desert sun. The solution may already exist, 200 miles to the west. California's Project Nexus is testing an elegantly simple concept: cover the canals with solar panels. The panels provide shade, slashing evaporation by up to 80% in some conditions. Simultaneously, the cooling effect of the water beneath boosts the efficiency of the photovoltaic cells by keeping them from overheating. It saves water, it generates power, it turns infrastructure into a symbiotic shield against the sun. Arizona is watching closely. The question is not whether solar canopies work, but how quickly they can be deployed across 336 miles of exposed canal. Arizona is engaged in an all-out war against aridification. They're building elevators for water, turning sewage into drinking supplies, and designing shields to protect their canals from the sun. The engineering is brilliant. The technology is proven. The question that remains is whether brilliance can outrun geology. The interconnection facility breaks ground in 2027 if the funding holds. The purification plants are expanding, but not at the pace of the shortage. The solar canopies remain pilot projects while billions of gallons evaporate overhead. And beneath it all, unregulated wells continue to drain the aquifers that were supposed to be the last resort. The Arizona paradox was never just about two water systems flowing in opposite directions. It was about a civilization engineered for abundance, now scrambling to survive scarcity. A system where one city spills water while another rations it, where technology races against time, where the rules protect some and abandon others. The Colorado River does not negotiate. It does not wait for construction timelines or legislative sessions. It is a patient executioner, and it is steadily tightening the noose. The interconnection facility, the purification plants, the solar canopies. These are not just infrastructure projects. They are the final line of defense for a civilization that chose to bloom in the desert, and they will determine whether the Arizona paradox becomes a story of adaptation or a cautionary tale of collapse.